Welcome to another Anyone Can Code video. As you may have known, my name is Yuma and I am 10 years old. I have made several apps and published them on the App Store, and today we're going to make an ARKit game. For your information, AR or Augmented Reality puts digital objects into the real world. I believe this is going to be the next big thing. So now I'm going to show you what we're going to make. It's like a King Kong kind of simulator where you tap on planes and they'll just come crashing down below. So here's a tracker, and this determines where you're going to place the game. So you tap to start the game and it'll be placed there. And because it's an AR, you can look at these buildings and move around them and go closer to them for more detail. And now we'll have planes just appearing out of the sky, and you tap them to make them explode and will just be sent down. And on top there's a score, and that determines how many planes you've destroyed. So let's get started. So before we begin, I have been working on a new ARKit game that has been featured on the App Store, both in Australia but also internationally, and I am very proud of it. So I shall present to you Let's Stack AR. The new iOS is out, and it's such an amazing upgrade. But the most exciting thing is Augmented Reality, or ARKit. Ever since I came back from WWDC, I've been working so hard to make a game out of ARKit and SceneKit. And now I have Let's Stack AR. The aim of the game is to stack the highest tower of blocks, and because it's an AR, you move closer to get precise placements. At the end of the game, you can see how tall your tower is and compare it to real-world objects. Well, what do you think? I hope you enjoyed it, and please get the game in the link down below and share your tallest tower on social media with hashtag Let's Stack AR. And now back to the tutorial. So let's get started. Okay, so let's open up Xcode here. And first of all, you should make sure that you have a device and that is plugged into your Mac. And you also have iOS 11 on your device. And also, your Xcode is Xcode 9, which supports iOS 11. So let's create a new Xcode project. And it's going to be an augmented reality app, as always. So yeah, just click augmented reality app and make sure your content technology is SceneKit. So let's name this Monster Monstache AR. So it's Monster Augmented Reality. It's okay. Bad pun, but it's not intended for a pun. Anyway, so there you go. So first of all, let's just see what we have right here. So we have a V controller, and let me just run you through this. So this is setting up the scene view. So this is the delegate, so we can actually listen for any like disruptions, or we can do rendering, or actually like estimation. So we can determine how bright ARKit can actually determine how bright uh, your environment is. So that's really good. So let's see here. And we're going to, so that enables the statistics, so you can know the frames per second and the just the information. And here it's creating a new scene, ship that I see here. So there's a ship and it's texture. Anyway, now this actually gets puts a scene in the scene view, so it can run. So and then now view will appear. So before the view appears, it actually creates an augmented reality tracking configuration. And then now the scene view runs it. Okay, so that's the configuration. And then now when the app will disappear or it's quit, presses the home button, the scene view will just pause the session and the configuration. But it's actually not really pause, it's actually stopping it, and then it just removes it, throws out the window. And here this is just the here this is when it creates a node, then yes, and then it will it'll get an anchor point, and then for that it will create a node with that. Well, it'll actually run that function, so you can create a node for that. So yeah, and here this is where it failed. You can delete that. Just delete the stuff. Like this is when it's interrupted, and the interruption ended. So yeah, interruption is like when the person moves around too quickly, or it's too dark, or yes, the floor is too shiny, so it can't keep up and keep the scene together, because then it would drift away. Anyway, let's see what we have. Let's run it. Okay, so this is the game at work. So now it asks you if the game will access the camera. Click OK, because else it won't actually be able to. You won't be able to see this ship in action. And now you can move around it, and this seems really cool. But we need to place it on the ground. Well, we need the scene to be on the ground. We don't want buildings to be floating in the air. So that's why we need a tracker, which is basically a visualization. And then you can tap, and it will just place the game. Okay, so first thing we need to do, we have to create some variables. So first of all, we need to create the visualization, the tracker. So tracker node. So var tracker node equals to scn node. There we go. Let me just stop this. There we go. And then we do var. So we also need to do a boolean to check two things. The game has started and is running, which we're going to use in part 2 of this series, of this tutorial. And we also need to check if the surface has been detected. So then we can, that's also used for part 2. So var game has started equals to false, and var found surface equals to false. Yeah, so we also need to get the game position, which will be an SEN vector free. Free make. I prefer free make instead of the instantiate. Anyway, so this basically, for 3D point. So X is horizontal, Y vertical, as you may have known, and Z is basically towards the camera. So like this. So we're gonna set this to 0, 0, 0 as a default. And then now in here do render update at time. So this will just do a render, like update every frame. And then now we need to check if the game hasn't started. So if guard game has started, and we're using guard. There's if and there's as you might have known, but there's also guard. So guard is like an if, but it's just one line. Very good. So this is just if, like statement, but it's guard. Then this is this statement. So if this is true, then it can pass through these below lines, the lines below. And if it doesn't, so else, then it'll do this. And in this case, we'll return, which stops this, like it gets out of function. And then now the game hasn't started yet, so now we can do a hit test. Now this hit test will find a surface here. So now we have to do the same thing, guard, and we can do guardlet, which is like the same thing as an iflet. And then guardlet hit test equals to scene view dot hit test with these one types, and this will, like I said, it'll just find a surface. And then now we can do a point, which we can find a surface in the middle of the screen. Well, it can be any place, but we're going to do it in the center of the screen. So CG point, and we're going to do view.frame.mid x. So it's a middle in x, like this. And then we're going to do, remember to do x here as it's instantiating. And then we're going to do view.frame.mid y. So just to ensure it's in this middle right here. So what's wrong? It's because we haven't added the else return. Anyway, here is the result types, and well, basically it's like we can get the one from the existing plane, or the feature point, or estimated horizontal plane. So I'll just do existing plane and feature point. Just keep it simple. Okay. We got to just this misspelling. View. Okay. So because this returns actually an array, but it's not optional. So we want to get the last one, and the last one is the one that's furthest away. So now once we've got this hit test and it's all successful, get the hit test. So we're going to get a transform, and more detail on that a few seconds later after I've done this. SCM matrix 4, and then hit test dot world transform. Now SCM matrix 4 is like a table as in like chart, but it has 4 rows, 4 columns. Now and then world transform from this hit test will just get this all the rotations and the positions, and So there we go. Yeah, it's in matrix form. So it'll have like M11, M12, M1, M21, M31, and M41. So there's 4 rows, and so M1, and then M2s, M3s, and M4s, and then the M0 is, yeah, you'll see. So now we need to get the position. So we're gonna set the game POS position equals to assume vector 3. If we're gonna get trans, and we're gonna get the trans.m41, which is the first part of the last row, the first column. So the last row is basically all the position stuff. So trans.m41, trans.m42, then transform.m43. Yeah, there is M44, but M44 doesn't do anything because positions have only 3 dimensions. It's a 3-dimensional position, basically. And then now, here we can set the tracker node, and now we need to check if it has found the surface before, so we don't constantly make tracker nodes and it soon becomes not work instead of a game. So we have to do if it hasn't found surface further, and then here we'll do let the tracker plane equals to SCM plane. There we go. And then width and height. So a plane, it's not the plane which you fly in to go to Hawaii or wherever you want to go. It's a flat it's basically like a square, but it's like just completely flat. It's flat. And so we need a width and a height. There's no length. Length is nup, 0. So for width and the height, the measurement is going to be meters. So we're going to do 0.3, which is 3/10 of a meter, or 30 centimeters. And then we're going to do the same thing with the height. Now we should actually have an image for this plane. So there's like a texture, which is like the image, say there's like an image here or a color like white for the plane. So it has a color on it. And here I'm gonna get the image. And if you want to be the same image I have, it's gonna be in my GitHub account. Yeah, it's gonna be on my GitHub account, and you can just get it. Just get it. It's for free. It's free. And then now I can go tracker plane dot first material. So we're gonna get the first material. There's only one material in this tracker plane. There's only going to be one. Dot diffuse, which is the thing we're doing. There's reflective. There's emission, but we're gonna do diffuse dot contents. Now we're gonna set those contents to UI. You can do UI image with named blah blah blah, or you can do it something that's called an image literal. So just type in the name of the image and boom, it's right there. That's a sweet and handy thing from the Xcode 9, but it's actually in Xcode 8, or no, I don't think it was in Xcode 7. Yeah, so now we can set the tracker tracker node to an SCN node, and with the geometry of the tracker plane. So the tracker plane is actually not the node we're looking for. It's actually just a geometry, just a shape for the form for the tracker, for the actual node. So now we have this tracker node, and now we're on our way to actually doing this tracker. So tracker node now we're gonna set the position to the game POS. We should actually put that outside because it's going to constantly move it. So yeah, and then now we can just add it. So scene view dot scene dot root node. So we're going to a scene view. The scene view scene, as you may have saw shipped our scene, and then we're going to dot root node, which is the root node of the scene, which you can put stuff in, and then add child node, which then we can put our tracker node into the scene, or more specifically the root node. So yeah, we don't want this to be run multiple times, so we just set found surface below to true. There we go. And that means this will only be run once, and it'll only be made once, and it will constantly be moved. So let's run it. See if it works. Yeah, here it is. Well, it actually works. It moves around. Yes, you can't tap it because it's not functional and the game's not there yet. But yeah, there it is. It's vertical, so but it needs to be like this. Can't be like this. You can see my hand, right? So we're just gonna make it flat down. Now we're back here. Plus in. How did I press in when I was doing that? But anyway, let's make this face down. Now, at first we'll see. Whoa, what is happening? Oh no! Oh, she does not like to say. What should I do? Okay, but here, let me tell you. The tracker node, or all nodes have this thing called Euler angles. Euler angles. And Euler angles is just rotation. So yeah, it's just rotating. So yeah, it comes in a SCN vector 3. Now there's X, Y, and Z. So X actually rotates around that axis for X, Y, and Z. So X, it rotates around the X, so it goes up and down, or it's called pitch. Y is around here, which is yaw, and then Z is basically like this. And it's called, yeah, so Z is roll, and well, for your information, roll is just rolling, like how my head is rolling, how this pen is rolling. Can't see, but it is rolling. So yeah, so we're gonna change a pitch, or X, and that's gonna be it's in radians. So the pi times minus 0.5, so it'll just go down, or like this. Like if you do times 0.5 without the negative, it'll go like this, and it'll face the underside, but there is no underside, so you'll see nothing. So you have to go the other way, which is minus 0.5, so you can see the top side. Yeah, so let's see tracker node, I guess, sort it out. Oh, first the plane. But we're here to look at the tracker. So it's facing down and it's functional. I mean, it's actually not functional because you can't place a game there. We haven't sorted out the game yet, but works. Okay, so that's a tracker. But we're not gonna do everything right now, so we're gonna stop it, and we're going to go. We're going to do the planes and the buildings in part 2. So until then, goodbye.